All right, this lesson is lesson 7, lines and angles. Now there's a bunch of vocabulary and some pictures in your book, so I would love for you to read through page 38 and 39 as we go through this together. Again, this is the warm-up. Go ahead and do this on your own for fun. Maybe fun's not the right word, but go ahead and do it. Get that brain warmed up and check your answer in the back. I think I have some a help or a clue right there. All right, now we're going to dive into our vocabulary. Space in math is the world of 3 dimensions. We don't always work in all 3 dimensions in math. Sometimes we're just, especially in geometry, a lot of times we're just doing 2 dimensions. And when we are dealing with just the 2-dimensional world, we're in a plane, okay? Not a plane that flies in the sky. A plane, the best I've ever been has described it, is a piece of paper that goes on and on and on forever with no thickness. Okay, so it's just the 2-dimensional with no depth. Everything has a length and a width, but no depth. Okay, so a plane is a 2-dimensional world. A 1-dimensional world, so we don't have a length and width. 1-dimensional world would just be a line. So far in math, you've been mainly staying in the 1 and 2-dimensional worlds, especially the 1. All right, a point has no dimensions. It has no thickness, no width, no length, has no dimensions. Now, this might be a little mind-boggling, but we have to use pictures. So if I have a point, it looks like it's thick. It might look like it's 1 millimeter long, but we are limited in real life to draw pictures or make illustrations of ideas. So that's where there's a little bit of a jump there, where things become a little more abstract in math. But that's what makes it fun and exciting. All right, a line contains an infinite number of points, okay, in between its endpoint. Well, no, actually, a line has no endpoints, sorry. So it has an infinite, sorry, I'm going to write it. I have to move my camera just a little bit. It gets a little hard. An infinite, a line, whoops, is an infinite. Now it's good for you to start practicing spelling on these math terms. They will not go away. They're going to continue on and on in your life. So I want you to make sure when you have a chance to spell them correctly that you do so. All right, a line is an infinite number of points. Now we're going to go off we're going to go beyond this. Sorry about that. Number of points extending in opposite an infinite number of points. Now this is in your book too, so in opposite directions without end. Now how do we draw that? How do you draw out something that never ends? Well, we have to draw it by using symbols and arrows, because we couldn't really draw a line that never ended. It would go around. Well, we can't even do that on Earth because it would end up curving to go all the way around the Earth, and that's not a line. So then we'd end up in a 2-dimensional world. So see how this stuff gets a little weird in real life, but we just have to use symbols to describe them. All right, so here is line AB, or we could ignore these and say there is segment AB on line AB. There's lots of ways we could call, there's a ray, and this is all I want you to read, 39, about rays and segments and all that, and how we describe those using symbols. All right, now we're going to jump to example 1. Use symbols to name a line, 2 rays, and a segment in the figure at the right. So symbols to name a line. The way we do that is you would have line AB with an arrow on it, or you could have had this. They're both correct. Okay, so we just described a line. Now let's describe two rays. How about from A, if this was the end point and it goes on and on forever in the direction of B, we're going to say segment AB. So there's one ray, or segment, sorry, ray AB, ray BA. So there we've gotten our two rays listed. And a segment, so our segment would be AB with a non-arrowed line on top, or we could say BA. Okay, so when we want to name things using symbols, these are the symbols. This is how we do lines, this is how we do rays, and that's how we do segments. All right, let's put some calculation into this. Let's look at example 2. It says in the figure below, AB is 3 centimeters and AC is 7 centimeters. Now, whenever we get a problem like this and they give you a picture and some dimensions, I go ahead and write them on there so I can see. So AB is 3 centimeters and from here to here is 7. So I'm going to go ahead and write 7 centimeters. So I have a visual. So this is 3, the whole thing is 7. Once you have the visual, it's pretty nice and easy to see what BC is. If this is 3 and the whole thing is 7, well then this missing part must be 4 centimeters. So if it says find BC, we're going to say BC equals 4 centimeters. Okay, now notice that there's no line on BC in this case. When you are doing, when we're actually giving measurements, it doesn't get the line on top. Don't ask me why, it's just part of, you know, the general way we do geometry. All right, now there are 2 more pages in your book, page 40 and 41. I really want you to look at those pictures, and they talk about intersecting lines, parallel lines, oblique lines, and angles and vertexes of angles and all that stuff. I really want you to look at those. It is review, which is why I'm kind of skipping through it. But we do get to write down what those definitions are. All right, a plane, now we just kind of talked about this, is a flat surface that extends without ending. A flat surface that extends without end. Okay, then we move on. If 2 lines cross, we say they, if 2 lines cross, we call them, they say that we intersect, they intersect at 1 point. They can't intersect at more than 1 point, or else one of them would not be a line, or they're the same line. All right, if 2 lines in a plane do not intersect, they remain the same distance apart the whole time. So I'm going to say the same distance apart. Sorry, I'm on a bump on the table. They are going to be called parallel. Now please learn to spell this correctly. The first L is double, the last one is a single, so P-A-R-A-L-L-E-L. All right, lines that intersect and form corners, square corners. Okay, so they still intercept at a point and they make square corners. Now there are pictures of this on page 40, so make sure your book is open. Lines that intersect and form square corners are, now again, good spelling word here, perpendicular. Okay, make sure you spell that correctly. All right, oblique lines are lines that will actually they intersect, but they're neither parallel nor perpendicular. So are neither, good, we get to practice spelling parallel again. Neither parallel nor perpendicular. So they cross, but not in any special form, not in right angles. All right, now let's jump to angles, okay? An angle is formed by two rays that have a common endpoint. By two rays that have a common endpoint. Again, there's pictures in your book. The common endpoint of an angle is called the vertex. That's a very important word. Well, all these are important words, so I want you to engage when you write these and think about them. All right, the rays of an angle are called the, really tough word, sides of your angle. All right, then I want you to actually read through the examples on your own, 3 through 5. And they're just showing you how we want things labeled and described. Okay, so we're going to be learning about or looking at parallel, perpendicular lines, angles that are made between lines, and then they use a real life situation, a parable. So I want you to please read through those. Now the practice I have listed on here, A through I, go ahead and do them on here. Check your answers in the solutions manual and correct or redo any that you made a mistake on. All right, so enjoy that. Again, it's some geometry, even though we're doing pre-algebra. It's fun that we mix it up a little bit.